Good afternoon, everyone. Welcome to the information session for ocean engineering. My name is Dr. Heng Xiao. The name is underlined here. So the purpose of the info session for today is to inform you about your major choices, and it has been probably a lot of fights, and along the way you have to basically exile from your high school, from your get into College of Engineering. Now you're faced with this problem: which major should I choose? So the info session today is to give you an introduction of ocean engineering. Yeah, it's not a big major. We are probably a third or a quarter of the aerospace and ocean engineering department, but it's a very exciting major, and maybe some of you have never heard of it in the news, but you definitely have seen in the news. Some of you, at least, have seen that in the news that there is a ship called Ever Given. It's a huge cargo ship, and somehow it got grounded to the New River, and then there's a huge backlog of other ships, and then the many things get delayed, and the oil price in the market get increased quite dramatically. So ships are out of your sight. You don't see them very much, but they are responsible to a big part of your life. And if you go to Walmart, most of these goods are shipped or carried from other parts of the world, many from China, but also from many other parts of the world, to here with ships mostly. Okay? And of course, the last 100 or a couple of 100 miles are with trucks, but the majority of the trade is with cargo ships. And before they even, let's think if they are produced in India or Bangladesh or Thailand or China, even before they were shipped out of there, they have made many trips even before they get shipped from that origin. Okay? They may have been, for example, a T-shirt. They may have been shipped, fabricated, or in India, and then they sew it together and then sent to Honduras in Central America to get printed, and then sent to the U.S. and so on. So ships is a big part of it. Now, you would ask them, what does this have to do with ocean engineering? Well, what is ocean engineering? Yeah, is it engineering the ocean, or is it studying how ocean circulate and so on? This is on this corner. Right? You can see that this is one of the animations of a simulation from NASA showing the currents in the ocean. Well, yes, it's part of it's related to the ocean, but by ocean engineering, we do not mean that we are engineering the ocean where we are studying the ocean. Instead, we are talking about engineering vessels that goes into the ocean, including yachts, or you can see it here is a submarine, and underwater autonomous vehicles, and ships, and destroyers, cruisers, and of course even aircraft carriers, and so on. These are what we call ocean engineering. It's a little bit of a misnomer, because in other places of the world they call it naval architecture and marine engineering, or more commonly used naval architecture. Okay, but when people say aerospace engineering, you don't misunderstood it as say, hey, are you engineering the air or the space? No, neither of this. It's about aircraft and spacecraft, right? So you can think of the ocean engineering as ocean craft or seacraft, including all the vehicles. Okay? So before I start the rest of the slide, yeah, I hope you can see the video. This shows you a very cool ASV, autonomous vehicle, the surface vehicle, ASV.
Little Metal Shark Boats and ASV Global have joined forces to introduce SharkTech autonomous vessels. SharkTech, featuring the ASView control system, is now available on Metal Shark's entire portfolio of globally proven designs, bringing autonomous capability to market in turnkey form, straight from the OEM. With multiple control modes, SharkTech offers crew reduction at the flip of a switch, allowing operators to choose conventional human operation, autonomous operation with a reduced crew, or fully autonomous unmanned operation. SharkTech vessels may also be operated via remote control, either from onboard the vessel or nearby mothership. Beyond simple waypoint navigation, the execution of pre-programmed mission routes, SharkTech features dynamic collision avoidance with robust decision-making capability. The system considers data from radars, daylight and thermal cameras, and AIS to safely identify and steer clear of stationary and moving obstacles. SharkTech allows for the autonomous or remote operation of navigation and safety lighting, hailers and sirens, and other components. SharkTech also supports the autonomous or remote operation of equipment for firefighting, hydrographic survey missions, pipeline inspection and mapping, and other specialty use, making it ideal for a wide range of markets. SharkTech autonomous vessels. Reliable autonomous vessel technology.
Okay, so apparently this is from one of the companies. I have nothing to do with the company, but the one of the presenters. Oh yeah, I forgot to show that this presentation was put together by myself along with my colleagues, and those are the 4 of the ocean engineering faculty members, and one of them, Dr. Christine Gilbert, she was on board this vessel, and she brought this. Showed this when she presents, she can relate more to her experiences. Yeah, but it's very cool to say that things can be quite exciting. So, what does ocean engineers study? Okay, so it consists of several aspects. In order for your ship, okay, we use ship to refer to all of this, but it could also be submarines. In order for your ship to execute a mission, it has to satisfy certain requirements. One of them, and the most important, one of the most important aspects is the stability. Okay, you should be able to stay dynamic and static stability. And many of you have played with paper airplanes, right? You use letter paper, and then you fold a kind of an airplane, and then say how far you can go. A lot of times, things can go wrong. Basically your paper airplane could plunge into the underground, right? This is because it lacks dynamic stability. And in the same way, your ships and submarines also needs to maintain stability. This is probably one of the most important aspects that is very unique. Okay, and then you need to be able to stay afloat and propel very efficiently. You have to be very hydrodynamic, and so people sometimes also say aerodynamic, but in water it's called hydrodynamic. So you need to know hydrodynamics, and that can be quite challenging. You can see this surface vessel are piercing in the wave. This is much more exciting than aircraft cruising in the air. Okay, that in that case is probably more like a submarine that is surrounded by water versus air. But here you can see that it's piercing at the interface between the air and water. Things can get very complicated and very exciting. Okay, and then of course you need to maintain structural integrity, right? If there's a wave, and you should stay intact. Okay, so you should not only support the self weight, but also support the cargoes that is on board. And then you need to propel efficiently. You can see that here is the propeller. Okay, how do you design this such that you can use as less fuel as possible and propel as efficiently as possible, right? Why is that there are 3 blades here but 6 blades here? Okay? Why is that? You have two of the twin propellers here. You can see the jets, not one big one. Okay, so these are the things you have to consider when you design your ship. Okay, and so from stability, hydrodynamic efficiency, structural integrity, and propulsion, and also the dynamics and marine engineering. Okay, these are, you can see here. This is one of the world's most powerful diesel engine that was installed on a cargo ship. So you can see this is the person, and this is the engine. Okay, pretty massive. And here I think there's an oil platform. So this is so by normal standard, this is not a ship, but this is also part of the ocean engineering. The only difference between this oil platform and the ship is that it doesn't move. Okay, other than the first trip to be installed on in there, other than that, it doesn't move. But it also has to maintain stability, structural integrity, and hydrodynamics, and so on. So this is also part of the ocean engineering. Or you can also choose whatever you want to study. And these are from a selection of undergraduate research from our department. You can see this is the wind propeller in our wind tunnel. So interestingly, we studied the performance of a hydro propeller or a ship in the air, in the wind tunnel, not in a water tunnel. Okay, you could do it in a water tunnel, but it's equally valid to do it in a wind tunnel because the two disciplines are very much related. Okay, it's basically a vehicle cruising in the fluid or in the interface of two fluids in the case of a surface ship. Yeah, so many students register for the 4994 undergraduate research every semester, including summer. And some students are paid as an undergraduate research assistant, but some register as a research credit, and you will gain a lot of hands-on experience in the advanced concepts and technology. So in summary, the ocean engineers in our department, they study stability, structure, hydrodynamics, marine engineering, and ship dynamics, as well as other undergrad, and then they put together in a senior design. This is the one-year design that is people have designed submarines, ships, and aircraft. No, we're talking about ocean engineering. So there are also people are also have designed wind turbine and tidal turbine and so on. These devices that goes into the ocean by utilizing and leveraging all the knowledge you have learned here in all these sub-disciplines. So now let me answer your question. I mean, why are you in the same department as aerospace? Like, what does this to do? One is in the air, and the other, or in the space, and the other is in the ocean. They couldn't be too different, right? Couldn't be more different. Well, because it's the same concept, right? You have a vehicle that you want to maintain stability and the hydro or aerodynamic efficiency. You want to propel it efficiently. You want it to cruise in the environment. The environment is basically fluids, water or air. Okay, but we study them as the basically very similar media and the same thing. And because of that, you will see that most of the classes that ocean engineers take are the same as aerospace engineers. Okay, and in fact, there's only 4 classes that are specifically to each major, and as a result, you can have a double major if you take these 4 extra classes, because all the other classes are the same. Yeah, I'm in a very good position to introduce you this because I'm on the faculty of aerospace and ocean engineering for 8 years now. I have taught many of these classes from multiple of these disciplines. Other than structure, I think I've taught stability, hydrodynamics. My research is actually in hydrodynamics, and also I've taught marine engineering and propulsion. So I have had a flavor of a lot of things in this chart. And I myself actually have a degree in civil engineering, and I did some research in coastal engineering. So I was basically educated in a totally different discipline, but I find a lot of concepts in common. So basically, even between civil engineering, where they design and build basically a building or a bridge, right? It doesn't move, but a lot of the concepts are very much the same here, other than the stability, which is not very important, not the most important thing in civil engineering, but all the hydrodynamics, right? You have to be able to resist the wind, right? If you have a bridge, you have to be able to resist the water forces and structure integrity, right? You need to maintain structure integrity under external loads. These are all very similar concepts. So this is ocean engineering may not be a most popular major. Well, we are one of the two or three institutions that still offer this undergraduate degree. So that makes us very unique, and that makes our graduates highly sought after. So you will see later more on this topic. But as far as I know, among the research intensive, or also called R1 universities here in the United States, only Michigan, University of Michigan, and Virginia Tech offer the degree, and there are a few other institutions like Webb Institute, New Orleans, and Florida Atlantic. They may offer some related subjects, but they are not R1 research intensive institutions. So what can you do with that ocean engineering degree? Well, the answer is a lot, right? First, it's a general engineering, a very general engineering degree, right? You can work in mechanical, aerospace, and many other intersections, but specifically for ocean engineering, if you really have passion, you can work on sailing and motor yachts. You can see these boats and so on. America's Cup, if you heard of it, they definitely need a lot of experience from ocean engineers. And maybe not too surprisingly, wind turbine. Okay? You have, particularly for the offshore wind turbine, you have part that is immersed in the air, but also the base. This is not installed to the ground. Okay, it's floating. Could be floating because here it could be very deep. So you have to maintain a stability of the entire thing. Well, how do you do that? Well, it's you have to understand the stability, right? And you have to utilize the knowledge you have learned here. And there is, for this reason, there is definitely a value in combining aerospace and ocean engineering in the same curriculum to tackle the most complicated challenges in the new world, in the new century. Okay? So this is basically one very hot topic in the renewable energy that is intersection of the aerospace and ocean engineering. And I forgot to say that we are one of the only department that combines both disciplines in a very unified manner in one department. Actually, I do research in both aerospace and ocean engineering. I actually collaborate a lot with NASA. So you get the idea, yeah. And there are also many exciting development in ocean engineering, including the remote sensing. And you can see that you need to combine information from the space, right? This is a satellite. You can see part of the ocean, but you also need to maybe put some sensors on the seafloor to sense at the bottom of the ocean and combine this information to make the best inference. You know that the electromagnetic wave doesn't work very well. It doesn't penetrate too far in the ocean. So you really have to send something in the water in order to sense information there. And there are also, of course, intelligent analysis showing the supercavitation concept that for torpedoes and submarines and so on. And here is the a very concise table. So naval architecture and marine engineering, or also referred to as ocean engineering here, they are one of the most valuable degrees. And basically, a couple of years ago, or maybe a few years ago, I was out having dinner with the graduates of our major, ocean engineering. There are probably 30 of them, and I think a professor asking one of them, say, "Hey, how is it going with your job search? Did everybody get a job?" And the answer I heard was, anybody who wanted a job had a job, basically. So it's very highly sought after. One of the reason is that it's very sparse, right? The supply is very sparse. There's only a handful of institutions that offer that degree, and there is a demand because from many sectors. Traditionally, our graduates mainly find employment in the DC area and in the Hampton Roads region in Eastern Virginia. We have Newport, new shipbuilding. They can build aircraft carriers and so on, and they are serving as contractors. A lot of contractors for the defense sector. But in the past few years, there has been a diversification. People have found employment. Two of my students that I know of are found employment in the oil and gas industry and in renewable energy industry. So people have more diverse in they have more diverse interest in among our graduates. Yeah. So definitely this is a good value, and you learn something not very specialized. It's still a very general engineering degree. In case that you find that ocean engineering is not your passion, you are still equipped with the basic engineering skills. You are still very flexible in switching to other fields. Like I myself, I was educated in civil engineering. I never worked in civil engineering, but it equipped me with the engineering skills and math skills and the mechanics. Right? These skills that allowed me to do research in ocean engineering and aerospace engineering and become a faculty member here even. So I think ocean engineering prepare you for both, right? A general knowledge of foundation in engineering and physics and math, but also a niche that prepares you to work in a very specific naval architecture and marine engineering industry, and many other areas beyond, including renewable energy and oil and gas industry and so on. Okay? So these are the survey of the potential employers or the firms that have hired our graduates. So I think maybe these are not the household names, but just because not many people are familiar with those names, but they do make very advanced boats and so on, and they make those aircraft carriers, destroyers, and so on. Yeah. So just because you don't buy one of them doesn't mean that they are not famous. They're actually very famous in the in the field. Yeah, as I said, there are many other opportunities for ocean engineers, including oil and gas and marine renewable energy, and so on. Okay. Yeah, so this is there are many things that you can do in that major, and as you can see that this is I think HPS, human powered submarine. So basically, you design a submarine, and then you have a human there and piloting, and you make a competition along with other people, human powered submarines. Basically, that it challenge your testing, and every year they have to have a few people from the ocean engineering, because you do need to maintain stability and so on, as the things I discussed. So could be quite exciting. They're also, of course, working with people from other majors, mechanical and electrical and so on. But if you had ocean engineering or naval architecture knowledge, it can be a very valuable asset for those teams. And of course, it's a good place to test your what you have learned, right? And quite a lot of things. Yeah, so if you need more information, you can find us on all the major social media, Twitter, Facebook, Instagram, and you can also find more on our departmental webpage. If you just search AOE.VT, you'll see all these pictures and all these social media. All right, I think that's all I have to say. Okay, so I got a question asking that what is the process of double majoring in AE and OE? I believe that you basically fill a form and then you get some advice from our undergraduate advisor. We have a person basically advise you on those matters and point you to how to proceed to get a double major. So yeah, good question. So a related question is how long would it take to complete the double major for A and OE? So I I've heard that people may be able to got it in time in the 4 years of time, uh, but it's going to be pretty heavy, right? We are one of the department that requires one of the most credit hours. Not so heavy as before because we revised our curriculum to slash some requirement and make it optional and so on. But it's still very heavy and quite challenging, but it's worth it. So I think I have also heard people delaying for half a year to finish that and 4 courses, right? So it sounds like reasonable for an extra semester. So I can't say for sure because there are people even without double major or in aerospace and ocean engineering, they would delay anyway because they somehow caught up on something else. But I think it's possible. Let me put it more brief that it's possible to finish in the 4 years of time, but it's also quite usual to delay for half a year to allow yourself a little bit of time. Yeah. So as if I understand correctly, the double major doesn't require you uh, to do 2 designs. Okay. So there is another thing. I don't know if it is still there, but there's a dual major which requires you to basically really to do 2 designs in aerospace and ocean. Basically, you design a aircraft or slash spacecraft and submarine slash wind turbine and slash ships. But the double major doesn't require you to do that. It only takes you to do 4 extra courses, and you still do an ocean engineering design. Yeah. So it's not too big. I think if you're good at it, you can manage your time well. It's possible, very possible that you can get it in time, in the same time. Right? Good. Thank you for these good questions. I think it's good to clarify this. But if you are seriously interested in that, I do encourage you to inquiry our undergraduate coordinator. I think his name is Brian. So basically, those are the students. Those are the person to whom our students will turn to when they are not clear what courses to choose. Right? Sometimes you have to take all the prerequisites before you can take the next course in sequence. So they will advise this person, and he will Brian will advise you navigate through those sequences. Okay? So you should inquiry to get more detailed and confirmed information, right? So there's another question: are there any studying abroad opportunities in ocean engineering? I think I don't think these study abroad opportunity are specific to ocean engineering or aerospace. It's more like for the departmental or college level opportunities. Before the COVID, I think our department had an exchange program with the Hamburg Institute of Technology in Berlin. I don't know what happens now. And there are also some joint teams with Nürnberg University in the UK, but it's more operating at a departmental level. And I do have I don't know the very detailed information, but from my experience in interacting with a student, a student 3 years ago asked for a reference letter from me to apply for a study abroad opportunity in, I believe, is in Germany, and then he ended up continue his master study in Germany, and he was an ocean engineering student in our department. So definitely that it's possible, but I'm not 100% sure how did he go through a department level or major. I believe is anything like this will be operating under that departmental level. Yeah. So yes, it's possible, and yeah. So next question from Scott: do you declare that right away during the application that you want to major in both, or you just decide you want to decide later to add OE major? I believe you in the double major you have your main major, your first major, and then your second major. Yeah, it's not symmetric, right? So I believe that you still declare your major and then later add the other major. I mean, you could. I have seen people do both ways in my class. Okay? I got this information mainly from the students that show up in my classes. I have taught marine engineering. I've taught intro to ocean engineering. I have taught wave mechanics. And in these classes, I saw that people coming from the AE major because they double majored in OE. And I also see people, students that are the first major is OE, but then they double major. They have another major in the main. The second major is in AE. Yeah, it's more common that way. I haven't seen anybody majoring in different departments. I don't know why, but this is what I see. So I guess I think that you have to have a major and then add the other one by going through the paperwork. Okay. Again, I'm not official. My answer is not official because I'm a faculty member. I do not. I'm not in charge of the those paperwork and these things. My experience mainly from the fact that I interacted with the students in my major. I see the results. I mean, I don't know what kind of paperwork they declare and so on. But I've seen them quite a few number of double majors in the past years. Okay.